Till now we had studied about branch chain alkenes, and alkenes are the ones which do not consist of functional groups or double or triple bonds. So they just consist of carbon and hydrogen, and they might have branches which are basically substituents. So if you haven't done that already, do check those videos out and then come here. So for compounds which have double or triple bonds, that is, which are shown as 2 or 3 lines, the nomenclature slightly changes. Excuse me. So the first step for every alkane that we had discussed was the fact that you have to decide on the longest chain. So let's take the example of this chain: CH3, CH2, CH2, CH2 and CH2 and CH3. Now, based on our longest chain rule, we need to pick the, as the name suggests, the longest chain. So you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So when it comes to double or triple bonds, had it been just an alkane, we would have taken this chain, that is this one. Okay. But because it's having a double bond, the double bond should be a part of the main chain. Irrespective of how long it is, we try and make sure that the double bond is in the main chain. So because of that, this will be the main chain. So this has 5 carbon atoms. Despite just having 5 carbon atoms, because it has a double bond, it is the part of the, that is considered the main chain of, or rather the particular compound is derived from this long chain. So we need, so that's the first one. Secondly, when we have a double bond, then instead of writing pentane, we would write it as pentene. And if it had a triple bond, it would be wine. So for a double bond, it is ene, and for a triple bond, it is ine. That is the second rule. Now the lowest number is given for the carbon-carbon multiple bond. Now let's take this particular compound. So as we know, now I'll write the same thing in a different way. So CH3. So this is exactly the same compound, I just changed the way we write it. Okay, so there are 2 ways of numbering this particular compound. We can either write it as 1, 2, 3, 4 and 5, or it can be the other way around. So that will be 1, 2, 3, 4, 5. Now our double bond should be attached. The numbering should be given in such a way that our double bond has a less, the numbering for that would be less. So we will be considering the one in orange and not the one in pink. And the name of this compound would be, here you have an ethyl group at the second position. So 2-ethyl pent 1-ene. I'll give another example for the same. So you have, let's assume we have CH3, CH, a double bond, CH, CH2 and CH3. So the numbering can either be from left to right or right to left. So 1, 2, 3, 4 and 5, or it can be 1, 2, 3, 4 and 5. So we will need to pick the carbon atom which is going to have, the double bond should have the substituent here in this case is a double bond, and that has to have a lesser number, or the locus has to be less. So here it is 2 and 3. So obviously 2 is lesser, so we will be considering 2, and the name of this compound is pent 2-ene. Remember, when we talk about alkenes and alkynes, when we name it the locant for the double bond will be the previous atom. Suppose the double bond is between the fourth and the fifth carbon atom, then we'll be writing it as 4 whatever, ene or ine. Okay, and if it's like it's between the third and the second, it'll be 2. So the previous carbon atom, I always used to get confused with this actually. So you have to remember that we'll be using the locant for the double bond will be the one with the lesser number, and the locant compared to the 2 carbons the double bond is attached to, it will be for the lesser number again. The next one, the naming of the side chain is similar to what we discussed in terms for alkanes, that is branch chain alkanes. That's why we wrote 2-ethyl pent 1-ene. So 2-ethyl, that's the second carbon, has an ethyl group attached to it. So the naming process is the same in case of the substituent which is present. Now let's assume we have a compound which has a double and a triple bond. Okay, there the double bond is going to get the lesser number. So I'll give you the example and then you'll understand. So this carbon is having a triple bond, and then it's bound to a double bonded carbon, CH3. Now the numbering for this particular compound is given in such a way that the double bond has a lesser number than the triple bond. So 1, 2, 3, 4 and 5 is one way of numbering it. 1, 2, 3, 4, 5 is the second way. And the first way, you have the triple bond is attached to the first carbon and the double bond is attached to the third carbon. Okay, that is case 1. The second way, you have the double bond attached to the second carbon and triple bond attached to the fourth carbon. And we will pick this over this because we want the double bond has to have a lesser number than the triple bond. Okay, and this compound which has both an a double and a triple bond, which means it can be an alkene or an alkyne, right? But it is considered to be a derivative of the alkyne and not the alkene, which means this is just a complicated way of saying that it will end with YNE. So pent, 5 carbons. Okay, double bond is in the second position. 2-ene to denote the presence of a double bond, and 4-ine. So the next rule that we're going to be talking about is, suppose for some reason we are unable to include the double or the triple bond in the main chain, then that becomes a part of a side chain or a substituent. So for example, you have a CH2 with a double bond. It's called a methylene group. And if it's C2, let's expand and write it. Suppose it's CH3, CH2, CH, then it is an ethylene group. Suppose the double bond is present between these 2 carbons instead of the one which is joined to the main ring. Oh, sorry, this is ethylidene. I'm so sorry. This is ethylidene. Whereas if it is between the 2 carbon atoms of the ethyl group, it's called as ethynyl, or it's also called as vinyl. So such an example we obviously need to learn. So let's take the example CH2. You have a double bond and a CH, single bond CH, double bond CH2. Here it's a double bond. Now, irrespective of whatever we do, if we consider this chain has a double bond. If we consider this, sorry, if we consider this has a double bond. And if we consider this will obviously have a double bond. So we can't help but we have to add, we'll be taking in the longest chain. Okay, so that is 1, 2, 3, 4 and 5. This is the longest chain. And since if you notice, it's symmetrical, right? So even if you number it this way, it will have the same name. So first of all, in the third position, you have a methylene group. So 3 methylene, and 5 carbon atoms, which means the pent. So penta. And since it has 2 double bonds, it is denoted with di, similar to what we had learned when there are 2 substituents. Like if there are 2 methyl groups, we call them dimethyl or trimethyl. So di, tri, tetra, penta, hexa. So here there are 2 double bonds and they are at positions 1 and 4. 1, 4, pentadiene. So what we did was, since it's impossible to include the double bond in the main chain, we had to name them using this. We picked the longest chain to be 5 carbons long and it has 2 double bonds. Because, so 5 carbon long, that's why penta. And 2 carbon double bonds, so it's a diene, and its position is at 1 and 4. Between 1 and 2 it is denoted as 1. Between 4 and 5 it will be denoted as 4. So 1, 4 diene, and this is a methylene group and it is at position 3. So that's called as 3 methylene penta 1, 4 diene. With that we finish the nomenclature for compounds which contain double and triple bonds, that is basically alkenes and alkynes. First of all, we are trying to have the longest chain rule is modified in such a way that we try our best to ensure that the double and the or the triple bond, whichever is present in the main chain. And if it's a double bond, it's called ene. A triple bond is called ine. And if there are multiple double or triple bonds, they're denoted as tri, tetra, penta, hexa, etc. Now the numbering is done in such a way that the double and triple bond get lesser number. Now if you have both a double as well as a triple bond in the main chain, then priority is given in such a way that the double bond gets a lesser number. That's what we discussed here. And the compound is considered to be a derivative of the alkyne. So that's why you have ine in the end. It has both double and triple bond and it is considered a derivative of the triple bonded carbon chain. Next, for some reason, if it's impossible or if it's not possible for us to have the double or the triple bond as a part of the chain, the main chain, then we are using methylene, ethylidene and ethinyl or vinyl names for the respective groups which are attached. So in this compound, we had two double bonds and double bonded substituent. So that was given as 3-methylene, and then penta because 5 carbon atoms, and 1,4-diene because there are 2 double bonds in this carbon chain. In the next video, we will be discussing about compounds which contain a functional group. Before you check out that video, it is better that you brush up on your functional group basics. It will make it easier. There was a video that I did about functional groups that will probably help you out. So do check it out.